Did you know that the universe holds more stars than there are grains of sand on every beach and desert on Earth? It's a staggering thought, isn't it? And yet, that's just the beginning of the incredible mysteries waiting to be uncovered. Today, we're embarking on a journey to explore 22 hidden wonders of the universe, phenomena so extraordinary, they challenge everything we think we know about reality. From cosmic collisions that bend space and time to invisible forces shaping the very fabric of existence, these marvels will leave you in awe. Get ready to discover the universe's best-kept secrets, where the ordinary becomes extraordinary and the unimaginable becomes real. Let's dive in. Hidden deep within the fabric of the universe, an invisible force is at work, tugging at galaxies with a power so immense it defies comprehension. This is the Great Attractor, a gravitational anomaly located roughly 250 million light-years away from Earth. Picture this: entire galaxies, including our own Milky Way, are being drawn toward it at astonishing speeds, as if caught in the pull of a cosmic magnet. But here's the twist: we can't see it directly. The Great Attractor lies hidden behind the dense band of stars, gas, and dust that makes up our galaxy's plane, shrouding it in mystery and making it one of the most elusive phenomena in the cosmos. What makes the Great Attractor so fascinating isn't just its immense gravitational pull, but the questions it raises about the structure of the universe itself. Scientists believe it might be a massive concentration of dark matter, or perhaps a supercluster of galaxies so dense that its gravity dominates an entire region of space. Yet, despite decades of research, its true nature remains a puzzle. Efforts to study it are ongoing, with astronomers using advanced instruments to peer through the Milky Way's obscuring veil, mapping the motions of galaxies to better understand this cosmic enigma. The implications of the Great Attractor are profound. It challenges our understanding of how matter is distributed across the universe and how galaxies move on such vast scales. What's more, it hints at even larger structures in the cosmos, suggesting that the Great Attractor itself might be part of something even grander, an intricate web of gravitational forces that shapes the universe as we know it. As we ponder the mysteries of this colossal force, let's journey even further into the cosmic unknown. The next wonder we'll explore lies beyond the Great Attractor, in a realm where the universe's secrets stretch even deeper into the void. Deep within the vast expanse of the universe lies a place so profoundly empty it defies comprehension. The Boötes Void. Imagine a region of space stretching an almost unimaginable 330 million light-years across, yet containing almost nothing. No galaxies, no stars, no planets, just a near-perfect vacuum. This cosmic desert, named after the constellation Boötes where it resides, is one of the largest known voids in the universe. Its emptiness is so extreme that if our Milky Way were located at its center, we wouldn't have even known other galaxies existed until the 1960s, when telescopes became powerful enough to peer beyond its borders. What makes the Boötes Void so baffling is how it challenges our understanding of the universe's structure. Cosmologists have long believed that matter is distributed somewhat evenly across the cosmos, forming a vast web of galaxies and clusters connected by filaments. Yet, this void seems to defy that pattern, presenting a region of startling nothingness on an incomprehensible scale. Scientists have proposed theories to explain its existence. Perhaps it's the result of cosmic inflation stretching space to an extreme, or maybe it's a remnant of some ancient cataclysmic event. But the truth is, we still don't fully understand why this void exists or what its implications are for our understanding of the universe. The sheer scale of the Boötes Void is almost impossible to grasp. To put it in perspective, if you were to travel across it at the speed of light, it would take you 330 million years to cross from one side to the other. That's longer than the entire existence of multicellular life on Earth. Its emptiness isn't just a curiosity, it's a cosmic mystery that forces us to rethink how matter is distributed and how the universe evolves over time. But even in this void, there are whispers of structure. A handful of galaxies have been found scattered across this vast expanse, like lonely islands in an endless ocean. These galaxies, though few and far between, might hold clues to the void's origins. Some scientists speculate that they could be the remnants of a much denser region that was somehow emptied out over billions of years. Others suggest that these galaxies might be the seeds from which new cosmic structures could one day form. As we ponder the mysteries of the Boötes Void, we're reminded that the universe is full of surprises, places that defy our expectations and challenge our understanding. And just as we begin to wrap our minds around this vast emptiness, we're drawn to the next wonder, a celestial object so dense it bends the very fabric of space and time. A place where gravity reigns supreme and the rules of physics as we know them are pushed to their limits. What if I told you there's a place in the universe where a single teaspoon of matter weighs as much as a mountain? Welcome to the mind-bending world of neutron stars, cosmic remnants so dense, so extreme, they defy everything we know about physics. Born from the explosive death of massive stars in supernova, these celestial objects are the ultimate cosmic recycling project. When a star collapses under its own gravity, it crushes down into a sphere no bigger than a city, yet packed with more mass than our entire sun. The sheer density of neutron stars is almost impossible to comprehend. Picture this: a teaspoon of neutron star material would weigh billions of tons. That's like squeezing the weight of the entire human population into a single sugar cube. But it's not just their density that's astonishing. Neutron stars spin at unimaginable speeds, some rotating hundreds of times per second. Imagine a star the size of Manhattan whirling around so fast that its surface moves at nearly a quarter the speed of light. Then there's their magnetic power. Neutron stars have magnetic fields trillions of times stronger than Earth's. These fields are so intense they can warp the very fabric of space-time around them. And if that's not enough to blow your mind, consider pulsars, a special type of neutron star that acts like a cosmic lighthouse. Pulsars emit beams of radiation from their magnetic poles, and as they spin, these beams sweep across the universe like a strobe light. If you're in the right spot, you can detect these pulses of energy, some as regular as the ticking of a clock. But neutron stars aren't just fascinating cosmic oddities, they're also laboratories for some of the most extreme physics in the universe. Underneath their surfaces, matter is crushed into exotic states that we can't replicate on Earth. Protons and electrons are squeezed together, forming a sea of neutrons so tightly packed that they behave like a single, superfluid quantum entity. It's a place where the laws of physics as we know them start to break down, offering scientists a glimpse into the most extreme conditions imaginable. And just when you think neutron stars couldn't get any stranger, they do. Some collide with other neutron stars, creating ripples in space-time known as gravitational waves, a phenomenon that has opened up an entirely new way for us to observe the universe. But as incredible as neutron stars are, there's something even more extreme waiting in the depths of space. Something so powerful, so mysterious, it can trap even light itself. Are you ready to find out what it is? Black holes are one of the most mysterious and awe-inspiring phenomena in the universe. These cosmic behemoths are regions of space-time where gravity becomes so intense that nothing, not even light, can escape their pull. Imagine a place where the rules of physics as we know them break down, and the fabric of reality itself twists beyond recognition. That's the essence of a black hole. But how do these incredible objects form? Most black holes are born from the remnants of massive stars. When a star many times larger than our Sun exhausts its nuclear fuel, it collapses under its own gravity, triggering a supernova explosion. What remains is a core so dense that it warps space-time, creating a black hole. The boundary around a black hole, known as the event horizon, marks the point of no return. Once anything crosses this threshold, it's lost forever to the black hole's immense gravitational grip. In recent years, we've made incredible strides in studying these enigmatic objects. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's shadow, located in the heart of the galaxy Messier 87. This groundbreaking achievement gave us a glimpse of the extreme environment surrounding a black hole, confirming theoretical predictions and opening new doors for exploration. Yet, black holes are not just fascinating, they're also deeply puzzling. One of the greatest mysteries they present is the information loss paradox. According to quantum mechanics, information about the universe can never be destroyed. But when matter falls into a black hole, it seems to vanish completely, leaving no trace. This contradiction challenges our understanding of physics and continues to baffle scientists to this day. As we ponder the mysteries of black holes, we're reminded of the vastness and strangeness of the cosmos. And speaking of cosmic mysteries, our next wonder takes us to an event so powerful that it ripples through the very fabric of space-time itself, a collision between two black holes. But more on that in just a moment. Now, let's turn our attention to one of the most spectacular cosmic events in the universe, the collision of neutron stars. Picture two of these incredibly dense stellar remnants, each just a few miles across but weighing more than our entire sun, hurtling toward each other at unimaginable speeds. When they finally collide, the energy released is so immense that it ripples through the fabric of spacetime itself, creating gravitational waves. These waves, first detected in 2015, are like cosmic echoes, carrying the story of the collision across billions of light years. But that's not all. This cataclysmic event is also a cosmic alchemist, forging some of the heaviest elements in the universe. In the fiery aftermath of the collision, gold, platinum, and other precious metals are born. That gold ring on your finger, it likely owes its existence to a neutron star collision that occurred eons ago. This process, known as a kilonova, is one of the universe's most dazzling displays of creation. Observing these events is no small feat. Scientists use advanced detectors like LIGO and Virgo to listen for gravitational waves, while telescopes across the electromagnetic spectrum, from radio waves to gamma rays, capture the brilliant light show that follows. These observations not only confirm Einstein's predictions about gravity, but also provide crucial insights into how the universe creates and distributes the building blocks of matter. The significance of neutron star collisions goes far beyond their beauty. They help us piece together the origins of elements essential for life and even hint at the conditions that might exist in other extreme cosmic environments. It's a reminder that the universe is both a destroyer and a creator, constantly reshaping itself in ways that challenge our understanding. As we marvel at these cosmic fireworks, let's prepare to shift our gaze to something even more immense, a structure so vast it defies comprehension. Next, we'll explore a cosmic wonder of unimaginable scale, where the universe itself seems to stretch the boundaries of what we thought possible. Imagine a structure so vast that it stretches across 1/10 of the observable universe, a cosmic behemoth that redefines our understanding of scale. This is the Hercules-Corona Borealis Great Wall, the largest known structure in existence, spanning an astonishing 10 billion light-years. It's not just a collection of galaxies, but a colossal web of cosmic filaments, gas, and dark matter that defies comprehension. To put it into perspective, if you could travel at the speed of light, it would take you longer to cross this wall than the entire age of our solar system. But what makes this structure truly mind-bending is how it challenges one of the most fundamental ideas in cosmology, the cosmological principle. This principle suggests that, on a large enough scale, the universe should look roughly the same no matter where you are, uniform and homogeneous. Yet, the Hercules-Corona Borealis Great Wall throws a wrench into that idea. Its sheer size and density of galaxies hint that the universe might not be as evenly distributed as we once thought. This discovery forces scientists to rethink the very fabric of reality, raising questions about how such a massive structure could form and what it means for our understanding of cosmic evolution. And here's the kicker, this isn't just a relic of the distant past. The light we see from the Hercules-Corona Borealis Great Wall has been traveling for billions of years, giving us a glimpse into the universe's younger days. But what if there's more to the story? What if this wall is just the tip of the iceberg, hinting at even larger structures waiting to be discovered? As we grapple with the mysteries of this cosmic giant, let's turn our attention to another wonder, one that doesn't just stretch across space but seems to bend the very flow of time itself. What lies ahead is a phenomenon so strange, it challenges everything we know about the universe's timeline. Now picture this, you're an astronaut floating in the vast emptiness of space, approaching a black hole. As you get closer, something strange happens. Time itself begins to stretch and slow down. This isn't science fiction. It's one of the most bizarre and fascinating effects predicted by Einstein's theory of general relativity. Near a black hole where gravity is so intense it warps the very fabric of spacetime, time doesn't flow the way we're used to. For you, the astronaut, seconds might feel like seconds. But for someone watching from a safe distance, your movements would appear to slow to a crawl, as if you were moving through molasses. This phenomenon is called time dilation, and it's one of the universe's most mind-bending secrets. To understand why this happens, think of spacetime as a rubber sheet. A black hole is like a bowling ball dropped onto that sheet, creating a deep, steep curve. The closer you get to the black hole, the steeper the curve becomes, and the more time slows down relative to the outside universe. If you were to venture close enough, let's say near the event horizon, the point of no return, time for you would almost come to a standstill compared to the rest of the cosmos. It's as if the universe itself is putting you on pause, but here's where it gets even stranger. Imagine you and a friend decide to test this out. You dive toward the black hole while your friend stays behind in their spaceship. For them, watching you fall in would seem to take forever as your image grows fainter and redder, stretched by the black hole's immense gravity. But for you, time would feel normal and the fall might only take moments. By the time you reach the event horizon, centuries could have passed for your friend. It's a paradox that challenges our very understanding of reality. This isn't just theoretical. Scientists have observed time dilation in action. For example, clocks on GPS satellites, which orbit Earth at high speeds and experience weaker gravity, tick ever so slightly faster than clocks on the ground. It's a tiny effect, but it proves that time dilation is real and measurable. Near a black hole, though, the effect is magnified to an extreme degree, showcasing the universe's ability to bend the rules we take for granted. As we marvel at this cosmic quirk, it's worth remembering that black holes aren't just time-warping anomalies, they're also gateways to even more astonishing phenomena. Speaking of which, our next wonder takes us to a cosmic event so powerful, it outshines entire galaxies and reshapes the universe around it. But we'll save that explosive revelation for the next segment. Now, let's turn our attention to one of the universe's most cataclysmic events, gamma-ray bursts. These are not just ordinary flashes of light, they are the most powerful explosions ever detected, releasing more energy in a few seconds than our sun will emit in its entire 10 billion-year lifetime. To put it into perspective, a single gamma-ray burst can outshine an entire galaxy for a brief moment. But what causes such unimaginable bursts of energy? Most gamma-ray bursts originate from two main sources. The first is the collapse of massive stars, often referred to as hypernova. When a star many times larger than our sun exhausts its fuel, its core collapses under its own gravity, triggering a supernova. But in some cases, this collapse is so extreme that it creates a gamma-ray burst, shooting beams of intense radiation across the cosmos. The second source is the collision of neutron stars, dense remnants of dead stars. When these ultra-compact objects spiral into each other, they release not only gamma rays but also gravitational waves, ripples in spacetime itself. What's truly astonishing is that these events are so powerful they can be detected billions of light years away. And while they happen far beyond our galaxy, their effects could still reach us. If a gamma ray burst were to occur too close to Earth within a few thousand light years, it could strip away our ozone layer, exposing the planet to harmful ultraviolet radiation. Fortunately, the likelihood of such an event is incredibly low, but it's a reminder of just how dynamic and unpredictable the universe can be. As we marvel at the sheer power of gamma-ray bursts, another cosmic mystery awaits, one that involves a strange and enigmatic signal from deep space. What could it be? Stay tuned as we uncover the next hidden wonder of the universe. Imagine a signal so powerful it outshines an entire galaxy, yet lasts only a few milliseconds. These are fast radio bursts, mysterious, high-energy flashes of radio waves from billions of light-years away. First discovered in 2007, they've since become one of the most puzzling phenomena in the universe. What could produce such an intense burst of energy, and why do they vanish almost as quickly as they appear? Scientists have proposed a range of explanations. Some believe they originate from highly magnetized neutron stars known as magnetars, which release colossal amounts of energy in sudden bursts. Others speculate they could be the result of colliding black holes or even the remnants of dying stars. And then there's the more tantalizing possibility: could these bursts be messages from advanced alien civilizations? While that idea captures the imagination, most researchers lean toward natural explanations, though the mystery remains far from solved. Efforts to decode these bursts are ongoing. Telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, are constantly scanning the skies, capturing these fleeting signals. Each new detection adds a piece to the puzzle, but with so much still unknown, fast radio bursts continue to challenge our understanding of the cosmos. They remind us that even in the vastness of space, some secrets are still waiting to be uncovered. And speaking of cosmic mysteries, our next wonder takes us to a structure so strange, it seems to defy the very laws of physics. What could it be? Stay tuned as we dive into the enigma of the cosmic web, a sprawling network of galaxies and dark matter that shapes the universe itself. Now, let's turn our attention to one of the most baffling mysteries of the cosmos: dark matter. Imagine a universe where most of what exists is completely invisible: no light, no color, no way for us to see it with our eyes or even our most advanced telescopes. That's dark matter. It makes up an astonishing 85% of the universe's total mass, yet it doesn't interact with light or any form of electromagnetic radiation. So how do we even know it's there? The answer lies in gravity. Scientists have observed galaxies spinning at speeds that should tear them apart, yet they hold together as if an invisible hand is gripping them. This unseen force is the gravitational pull of dark matter. It's like watching a carousel spin faster and faster, but instead of the riders flying off, they stay perfectly in place because something hidden is holding them steady. But dark matter isn't just holding galaxies together, it's shaping the entire structure of the universe. When we look at the cosmic web, the vast network of galaxies and clusters stretching across the cosmos, dark matter is the scaffolding. It dictates where galaxies form and how they move. Without it, the universe as we know it wouldn't exist. Yet, despite its overwhelming presence, dark matter remains elusive. Scientists have been searching for decades to detect it directly, using ultra-sensitive detectors buried deep underground to shield them from interference. So far, no direct evidence has been found, but the hunt continues, driven by the tantalizing possibility of unlocking one of the universe's greatest secrets. And speaking of cosmic mysteries, this invisible force isn't the only thing shaping the universe. there's another, even more perplexing phenomenon at work, something that's not just holding the cosmos together but actively pushing it apart. What could it be? Well, that's a story for the next wonder. Now, let's turn our attention to one of the most baffling mysteries in the universe: dark energy. Unlike anything we've encountered before, this enigmatic force is causing the universe to expand at an ever-increasing rate. Think about that for a moment. It's not just that the cosmos is growing, it's speeding up as it does so. Scientists first stumbled upon this phenomenon in the late 1990s, when observations of distant supernova revealed that the universe's expansion wasn't slowing down as many had expected, but accelerating. This discovery turned our understanding of physics on its head. So, what exactly is dark energy? The truth is, we don't fully know. It's invisible, it's pervasive, and it seems to make up about 68% of the universe's total energy. Some theories suggest it's a property of space itself, a kind of cosmic pressure that pushes galaxies apart. Others propose it's tied to a mysterious field or particle we haven't yet discovered. What's clear is that dark energy is reshaping our understanding of the cosmos, challenging everything from Einstein's theory of relativity to the very fabric of spacetime. The implications of dark energy are staggering. If this force continues to dominate, the universe could face a cold, lonely fate known as the Big Freeze, where galaxies drift so far apart that the night sky becomes utterly empty. But here's the twist: dark energy also raises questions we can't yet answer. Why does it exist? How does it work? And what does it mean for the ultimate destiny of the universe? These are the puzzles that keep physicists up at night. As we grapple with these cosmic questions, let's not forget the wonders that lie ahead. Just as dark energy stretches the boundaries of our understanding, the next marvel we'll explore bends the very fabric of light itself. Stay tuned as we dive into a phenomenon that warps reality in ways that seem almost magical, a cosmic trickster that plays with the very essence of what we see. Now, imagine looking at the night sky and seeing the same galaxy not once, but twice, or even in a perfect ring of light. This isn't science fiction, it's the mind-bending reality of gravitational lensing. At its core, this phenomenon occurs because massive objects like galaxy clusters warp the fabric of spacetime itself. Just like a magnifying glass bends light, these cosmic giants bend the light from distant galaxies, creating astonishing visual effects. Sometimes, this distortion makes galaxies appear as multiple images or stretched into arcs like cosmic mirages. It's as if the universe itself is playing tricks on us, revealing hidden wonders we might otherwise never see. But gravitational lensing isn't just a cosmic spectacle, it's a powerful tool for astronomers. By studying how light bends around massive objects, scientists can map the distribution of dark matter, the invisible glue that holds galaxies together. These observations give us clues about the universe's structure and how it evolved over billions of years. And there's more. Gravitational lensing has even helped us discover exoplanets, worlds orbiting stars far beyond our solar system. When a distant star's light is magnified by a foreground object, even a tiny dip in brightness can reveal the presence of a planet hidden in the vastness of space. What's truly remarkable is how this phenomenon connects the very small to the unimaginably large. It shows us that the universe isn't just a static backdrop. It's a dynamic, ever-changing stage where light and gravity dance in ways we're still learning to understand. And speaking of cosmic beauty, this brings us to our next wonder, a structure so vast and intricate, it's like a masterpiece painted across the canvas of the universe itself. Among the countless marvels scattered across the universe, few are as breathtaking and iconic as the pillars of creation. Nestled within the Eagle Nebula, roughly 7,000 light-years from Earth, these towering columns of gas and dust stretch across light-years of space, standing as both a cosmic cathedral and a stellar nursery. Picture immense clouds of hydrogen gas swirling with dark, dusty tendrils, illuminated by the intense light of nearby stars. These pillars are not static, they are alive with activity, birthing new stars in a process that blends destruction and creation in equal measure. The name Pillars of Creation is more than poetic, it's literal. Deep within these columns, pockets of gas collapse under their own gravity, igniting nuclear fusion and giving birth to stars. Yet, even as new stars emerge, the intense radiation from nearby massive stars slowly erodes the pillars, sculpting them into their dramatic shapes. It's a cosmic balancing act where creation and destruction dance together in a cycle that has repeated for billions of years. What makes these structures so mesmerizing is not just their scale or beauty, but the story they tell. They remind us that even in the vast emptiness of space, there are places teeming with life, not biological life, but the life of stars, galaxies, and the very building blocks of the universe. The pillars of creation are a testament to the universe's ability to create beauty from chaos, a reminder that even in the cold void of space, there is warmth and light waiting to emerge. And just as these pillars captivate us with their grandeur, they also hint at even greater mysteries lurking in the cosmos. What lies beyond them? What cosmic phenomena could possibly rival their majesty? Prepare to be astonished, because our next wonder takes us into the realm of the truly bizarre, a place where the laws of physics as we know them seem to bend, twist, and unravel completely. Imagine zooming in on the fabric of space-time, closer and closer, until the smooth, continuous universe you once knew begins to dissolve into something far stranger. At the tiniest scales imaginable, space-time isn't the calm, unbroken surface we perceive. It's a chaotic, frothy sea, bubbling with energy and uncertainty. This is the realm of quantum foam, one of the most mind-bending concepts in modern physics. Here, the very structure of reality becomes a turbulent dance of particles popping in and out of existence, and space-time itself twists and fluctuates like waves on an ocean. It's as if the universe, when viewed under a magnifying glass, reveals a hidden layer of chaos beneath its seemingly orderly surface. But what does this mean for our understanding of the cosmos? Quantum foam isn't just a curious idea. It's a crucial piece of the puzzle in the quest to unify quantum mechanics and gravity. At these infinitesimal scales, the rules of Einstein's general relativity break down, and the smooth geometry of space-time gives way to a frothy, unpredictable landscape. This is where the search for a theory of quantum gravity begins, an attempt to reconcile the bizarre behavior of the quantum world with the grand, elegant framework of relativity. Yet, quantum foam also poses profound challenges. How can we ever observe something so small, so fleeting, that it defies our current tools and theories? It's a reminder that the universe still holds mysteries far beyond our reach. And as we ponder this frothy, fluctuating frontier, we're left with a tantalizing question. If space-time itself is so chaotic at its core, what does that mean for the nature of reality? Are we living in a universe that's fundamentally uncertain, where even the fabric of existence is in constant flux? Quantum foam doesn't just challenge our understanding of physics, it invites us to rethink what we know about the very ground beneath our feet, or rather, the space and time that make up everything we experience. As we step back from this microscopic chaos, our journey through the universe's hidden wonders takes us to something far grander, a cosmic structure so ancient it predates even the stars themselves. What could possibly exist in the depths of space that stretches back to the dawn of time? The answer lies in our next wonder, a relic from the earliest moments of the cosmos. From the vast expanse of dark matter to the brilliant flashes of gamma-ray bursts, we've journeyed through some of the universe's most astonishing phenomena. But now we turn our attention to something far quieter yet equally profound, a whisper from the very dawn of creation itself. This is the cosmic microwave background, or CMB, a faint glow that permeates the entire cosmos. It's often described as the afterglow of the Big Bang, and it holds secrets about the universe's earliest moments. Imagine, if you will, a time when the universe was just a hot, dense soup of particles and energy. About 380,000 years after the Big Bang, the cosmos had cooled enough for atoms to form, allowing light to travel freely for the first time. This light, now stretched and cooled over billions of years, is what we detect today as the cosmic microwave background. It's like a snapshot of the universe in its infancy, a relic of a time when everything we know, stars, galaxies, even space itself, was just beginning to take shape. But why is this faint glow so important? For scientists, the CMB is like a cosmic time capsule. Tiny fluctuations in its temperature, just a few millionths of a degree, reveal the seeds of structure in the early universe. These tiny ripples eventually grew into the galaxies and galaxy clusters we see today. Without the CMB, we wouldn't have a map of the universe's origins, nor would we understand how it evolved into the complex web of matter and energy we observe now. It's a cornerstone of modern cosmology, grounding our theories in observable evidence. As we marvel at this ancient light, we're reminded of how far we've come in unraveling the mysteries of the cosmos. Yet, the universe always has another surprise in store. Next, we'll explore a cosmic phenomenon that doesn't just challenge our understanding of space, it bends our perception of time itself. What could it be? Stay with us as we dive into the next wonder, where the rules of reality itself seem to unravel. Have you ever wondered why time only moves forward? Why we can remember the past but not the future? This is the mystery of the arrow of time, one of the most profound and puzzling concepts in the universe. Unlike space, where we can move freely in any direction, time seems to flow in one direction only, forward. But why? The answer lies in something called entropy, a fundamental principle that governs the universe's behavior. Entropy is a measure of disorder in a system. Think of it like a deck of cards. When it's neatly arranged, it has low entropy, but shuffle it, and the disorder increases, the entropy rises. The universe works the same way. Over time, everything tends to move from order to disorder. This is why ice melts, buildings crumble, and stars burn out. It's also why we perceive time as moving forward. The increase in entropy gives time its arrow, its one-way direction, but here's where it gets even more fascinating. If entropy dictates the flow of time, what does that mean for the universe's ultimate fate? Scientists believe that as entropy continues to increase, the universe will reach a state of maximum disorder, a state known as heat death. In this scenario, all energy is evenly distributed, stars fade, and no meaningful work can be done. It's a chilling thought, but it's also a reminder of how deeply interconnected time and entropy really are. The arrow of time also presents some mind-bending paradoxes. For instance, if the laws of physics are time-symmetric, meaning they work the same whether time moves forward or backward, why do we only experience one direction? This paradox has puzzled physicists for decades, and while we have some clues, the full answer remains elusive. Some theories suggest it's tied to the Big Bang itself, which set the initial low entropy state of the universe. Others propose that time's arrow might be a result of quantum mechanics or even the multiverse. As we ponder these mysteries, it's impossible not to marvel at how something as simple as the ticking of a clock connects to the grandest scales of the cosmos. And speaking of grand cosmic structures, our next wonder takes us to a phenomenon so vast and intricate, it challenges our very understanding of the universe's architecture. What could it be? Stay tuned, because the answer is as awe-inspiring as it is complex. Picture the universe not as a random scattering of stars and galaxies, but as an intricate, sprawling tapestry, a cosmic web woven together by gravity over billions of years. This is the large-scale structure of the universe, a breathtaking network of galaxies, filaments, and vast empty voids that stretch across the cosmos. It's like looking at the veins of a leaf or the neural pathways of a brain, but on a scale so immense it defies comprehension. This cosmic web is the result of tiny fluctuations in the early universe, amplified by gravity over eons, pulling matter into dense clusters and leaving behind enormous voids. These filaments of galaxies, connected like threads, form the backbone of the universe, while the void's vast regions of near-nothingness make up the spaces in between. Together, they create a structure that's both awe-inspiring and humbling, revealing the universe as a dynamic, ever-evolving entity. But how did this cosmic web come to be? It all traces back to the Big Bang, when the universe was a seething, chaotic soup of particles. Tiny ripples in density, barely noticeable at first, began to grow as gravity pulled matter together. Over billions of years, these ripples evolved into the filaments and clusters we see today, with galaxies strung along them like beads on a string. What's truly astonishing is that this structure isn't static. It's still growing, still changing, as gravity continues to shape the cosmos. And it's not just a pretty picture. The cosmic web holds clues to some of the universe's deepest mysteries, like the nature of dark matter and dark energy, which drive its expansion and structure. As we marvel at this grand design, it's hard not to wonder, what other secrets does the universe hold? What lies beyond the filaments and voids, beyond the limits of what we can see and understand? This brings us to our next wonder, a phenomenon so strange and elusive that it challenges everything we think we know about matter itself. A cosmic enigma that defies the laws of physics as we understand them, lurking in the shadows of the universe, waiting to be uncovered. Now, let's turn our attention to one of the most enigmatic substances in the cosmos, antimatter. If ordinary matter is the building block of everything we see around us, antimatter is its mirror image, its shadowy twin. Every particle of matter has an antimatter counterpart. Electrons have positrons, protons have antiprotons, and so on. But here's the twist: when matter and antimatter meet, they annihilate each other in a burst of pure energy. It's a cosmic dance of creation and destruction, and it raises one of the biggest questions in physics. Why is our universe dominated by matter, when both should have been created in equal amounts during the Big Bang? Antimatter isn't just a theoretical curiosity. It's real, and scientists have been able to produce tiny amounts of it in labs. The process is incredibly complex and energy-intensive, which is part of why antimatter is so rare. In fact, it's estimated that producing just 1 gram of antimatter would cost trillions of dollars. But its rarity hasn't stopped researchers from dreaming about its potential. Imagine a spacecraft powered by antimatter engines, capable of reaching distant stars in a fraction of the time it takes today. Or medical treatments that use antimatter to target cancer cells with pinpoint precision. These ideas might sound like science fiction, but they're grounded in real science. Yet, for all its promise, antimatter remains one of the universe's greatest mysteries. Why is there so little of it, and where did it all go? Some theories suggest that slight asymmetries in the early universe tipped the scales in favor of matter, but the truth is still out there, waiting to be discovered. Experiments like those at CERN are working tirelessly to unlock its secrets, and every discovery brings us closer to understanding this elusive substance. As we marvel at the strange nature of antimatter, it's worth reflecting on the broader implications. This isn't just about particles and energy, it's about the very fabric of reality. And speaking of energy, our next wonder takes us even deeper into the cosmos, to a phenomenon that bends the rules of physics and challenges everything we thought we knew about how the universe works. Stay tuned, this one will truly stretch your imagination. At the heart of our solar system lies a blazing furnace of unimaginable power, the Sun. But what keeps this colossal star burning so brightly? The answer lies in a process called nuclear fusion. Deep within the Sun's core, temperatures soar to an astonishing 15 million degrees Celsius, creating the perfect conditions for hydrogen atoms to collide and fuse into helium. This fusion releases an incredible amount of energy, radiating outward in the form of light and heat. Every second, the Sun converts around 600 million tons of hydrogen into helium, releasing enough energy to power our planet for millions of years. This process isn't just a cosmic curiosity, it's the very foundation of life on Earth. The Sun's energy fuels photosynthesis in plants, drives our weather systems, and warms our planet to just the right temperature for life to thrive. Without nuclear fusion, our world would be a frozen, lifeless rock drifting through the void. But the Sun's influence goes even further. Its energy shapes the entire solar system, from the orbits of planets to the formation of comets and asteroids. And the Sun isn't alone. Every star in the night sky is powered by the same process, each one a glowing testament to the universe's ability to create and sustain life. Over billions of years, the energy produced by stars has driven the evolution of galaxies, forging heavier elements like carbon, oxygen, and iron, the building blocks of planets, oceans, and even life itself. But as awe-inspiring as the Sun's power is, it pales in comparison to the next wonder on our list. Imagine a force so immense that it can warp the very fabric of space and time, swallowing entire stars and bending light itself. What could possibly be more powerful than the Sun? Stay with us as we explore a cosmic phenomenon that defies imagination, a place where the laws of physics as we know them break down completely. Picture this, a cosmic dance billions of years in the making, where two massive galaxies, ours and our neighbor, Andromeda, are on an inevitable collision course. In about 4.5 billion years, the Milky Way and Andromeda will meet in a spectacular merger, reshaping the night sky as we know it. But don't worry, this isn't a story of destruction. Instead, it's a tale of cosmic rebirth. When these galaxies collide, the stars within them are so far apart that actual stellar collisions are incredibly rare. Instead, gravity will weave them together into a single, larger galaxy, sometimes referred to as Milkomda or Milkdromda. This new galaxy will be a hybrid of the two, with a radically different structure and a night sky that would look unrecognizable to us today. What's truly remarkable is how this event challenges our perception of time. 4.5 billion years might feel like an unfathomable stretch, but on a cosmic scale, it's just a blink. And while the collision itself will take millions of years to unfold, it's a reminder that the universe is in a constant state of change, even if we can't witness it in our lifetimes. The stars and planets within both galaxies will survive, but their trajectories will be forever altered, creating a new galactic landscape. This collision also raises fascinating questions about the future of life in the universe. Could civilizations billions of years from now thrive in this new galaxy? Or will the merger bring about challenges we can't yet imagine? It's a reminder that the universe is vast, dynamic, and full of surprises, something we'll explore further as we delve into our next wonder, a phenomenon so strange it challenges everything we think we know about the fabric of space itself. What if our universe is just one page in an infinite cosmic book, with countless other universes existing alongside it? This is the mind-bending idea behind the multiverse, a concept that has captivated scientists, philosophers, and dreamers alike. The multiverse theory suggests that our universe is merely one of many, each with its own unique set of physical laws. In some, gravity might be stronger or weaker. In others, light could travel at a different speed, or matter might behave in ways we can't even imagine. It's a concept that stretches the boundaries of what we think is possible, and it's not just science fiction, it's a serious topic of scientific debate. So, where does this idea come from? One of the key pieces of evidence comes from the study of cosmic inflation, the rapid expansion of the universe just moments after the Big Bang. Some physicists argue that this expansion didn't just happen once, it could have happened repeatedly, creating countless bubble universes each time. Another line of thought ties into quantum mechanics, where every possible outcome of a situation might exist in its own separate universe. Imagine flipping a coin. In one universe, it lands on heads, in another, it's tails. Now, apply that to every decision, every event, and every moment in history. The possibilities are endless and mind-boggling. But the multiverse isn't just a playground for theoretical physics. It has profound philosophical implications too. If there are infinite universes, does that mean there's a version of reality where every possible outcome has occurred? Could there be a universe where dinosaurs never went extinct, or where humanity never existed at all? And what does that mean for our sense of purpose and uniqueness? These questions don't just challenge our understanding of the cosmos, they challenge how we see ourselves within it. While the multiverse remains a highly debated topic, it's a testament to humanity's relentless curiosity. We're driven to explore the unknown, even when the answers seem just out of reach. And speaking of the unknown, our next wonder takes us to a cosmic phenomenon so strange, it makes the multiverse seem almost ordinary. Get ready to dive into a mystery that bends the very fabric of reality itself. Now, let's take a step into one of the most mind-bending ideas in modern physics, the holographic principle. Imagine for a moment that everything you see, touch, and experience in the three-dimensional world around you is actually a projection of information encoded on a two-dimensional surface. Sounds like science fiction, doesn't it? But this is a serious theory that has been gaining traction among physicists. The holographic principle suggests that the entire universe, with all its stars, galaxies, and even you, could be like a cosmic hologram. Just as a hologram creates a three-dimensional image from a flat surface, the universe might be a vast, intricate projection of data stored on its boundaries. This idea didn't just come out of nowhere. It emerged from the study of black holes, where scientists discovered that the amount of information a black hole can hold is proportional to its surface area, not its volume. This odd finding led to the thought that perhaps the universe works the same way. If true, it would mean that all the complexity and richness of our three-dimensional reality could be encoded on a two-dimensional plane, like a cosmic DVD storing everything we know and experience. What does this mean for our understanding of reality? If the holographic principle holds, it could completely reshape our view of space, time, and existence itself. It suggests that the universe might not be as it appears, that what we perceive as depth and volume could be an illusion, a kind of cosmic trick of the light. This theory also bridges the gap between quantum mechanics and general relativity, two pillars of physics that have long seemed incompatible. By rethinking the nature of reality, the holographic principle opens up new ways to explore the deepest mysteries of the cosmos. As we near the end of our journey through these hidden wonders, the holographic principle reminds us just how strange and incredible the universe truly is. It challenges us to question not only what we know but also how we know it. And as we prepare to wrap up this exploration, let's take a moment to reflect on how these mind-blowing discoveries reshape our understanding of everything around us and perhaps even ourselves. As we come to the end of this journey through the 22 hidden wonders of the universe, it's impossible not to feel a profound sense of awe. From the haunting beauty of black holes to the intricate dance of distant galaxies, each of these phenomena reminds us just how vast, mysterious, and utterly breathtaking the cosmos truly is. These wonders aren't just scientific curiosities, they're windows into the deepest questions about existence itself. What does it mean to live in a universe where time can bend, where stars are born and die in spectacular explosions, and where entire galaxies collide in a cosmic ballet? These discoveries don't just challenge our understanding, they ignite our curiosity. They push us to ask bigger questions, to rethink what we know, and to dream about what we might still uncover. Every star, every galaxy, every unexplained phenomenon is a reminder that the universe is far stranger and more magnificent than we could ever imagine. And yet, for all we've learned, there's still so much we don't know. What lies beyond the observable universe? Are we alone in this vast expanse? These questions don't just belong to scientists, they belong to all of us. So, what's next? The universe is waiting for you to explore it. Whether it's through a telescope, a book, or simply gazing up at the night sky, there's a whole cosmos out there to discover. Share your thoughts in the comments. What wonder captivated you the most? What questions about the universe keep you up at night? Let's keep the conversation going, because the more we learn, the more we realize how much there is to marvel at. The universe is full of mysteries, and every discovery brings us one step closer to understanding our place within it. Keep looking up, keep wondering, and never stop exploring. The cosmos is calling. What will you find?